No one? So remember, you have to do the corresponding sides. So we have the height right here and the height right here. So our first one, if we do the small one on top, it would be 5.5 divided by 35 would equal the base of our small triangle has to go on top since we did the height of the small triangle on top equals 10 over the side that we don't know, which is x. I'm sure some of you got that. You're just being shy. Okay, so now go ahead and solve for x and send me in the chat what you get for x once you've got it. Okay, good. I'm getting a couple answers. So we get, when we cross multiply, we get 5.5 times x, which is 5.5x equals 35 times 10, which is 350. Then we have to divide both sides by 5.5, and we see that x equals 63.64. Any questions? So the boat is 63.64. Oops, 63.64 feet away from the cliff. Okay, in the diagram below, a large flagpole stands outside of an office building. Marquis realizes that when he looks up from the ground, 60 meters away from the flagpole, that the top of the flagpole and the top of the building line up. If the flagpole is 35 meters tall, so here's our flagpole, that's 35 meters tall, and Marquis is 170 meters from the building. How tall is the office building? So we're trying to find this. We're trying to find H. Okay, so these are similar figures. So we just need to set up a proportion again. So we have our height here and then our height here. So that's going to be one of them. And then we have our base here, which is 60 of our small triangle, and the base here of our large triangle, which is 170. So go ahead and set up your proportions just like we did on the first one. Okay, so you should have gotten 35, over H equals 60 over 170. Okay, and then go ahead and find H. Very good. I'm getting all the right answers in the chat. Very good. So we cross multiply, and 35 times 170 is 5,950 equals h times 60, or 60h. And then when we divide both sides by 60, we get 99.17. And so the height of this building is 99.17 meters. And when a lot of you guys just put 0.16, that's fine. You would just round up, since the next number after the 6 is a 6, is why it's a 17. Very good. Any questions on the application? Okay, let's move on to the problem solving task. Okay, so the Hopewell people were Native Americans whose culture flourished in the central Ohio Valley about 2,000 years ago. The Hopewell people constructed earthworks using right triangles, including those below. Okay, so we have a bunch of right triangles. Number 1, what is the length of the hypotenuse of triangle H? So give your answer correct to 1 decimal place and show your calculations. So they told us these are all right triangles. So we can use Pythagorean Theorem, which says that a squared plus b squared equals c squared, to find our hypotenuse, which in this case, in case we forgot, let me just go through it in the notes. So you're having to use what you learned last unit. So for Pythagorean theorem, remember, first we want to identify and label A, B, and C. So remember, the side we're most concerned about is C, which is the hypotenuse. A and B don't matter as much. Then we just plug in A, B, and C to a squared plus b squared equals c squared, and solve. So we want to label our sides. This is our hypotenuse, which we don't know. So that's going to be C, which means these are A and B. Okay, and then go ahead and solve for the hypotenuse and send me in the chat what you get. So I think, let's see. Oh, I sent that to the wrong person. Yay, we're getting it. Very good. Okay, let's go ahead and go over it. I think most of us have it now. You guys got it. Okay, so A is 1. So we plug in 1 for A and square it, plus B, which is 7. We square that, equals C squared. 1 squared is 1 plus 7 squared, which is 7 times 7 is 49 equals c squared. So 50 equals c squared. Then we want to know what c equals. So we have to take the square root of both sides. And so we would do this on our calculator. The square root of 50 is 7.07. It says to round 1 decimal place. So we could round up to 7.1. Which everyone sent me that got it. Very good. Yeah, Jade, I meant to send that to someone else. Just ignore that last one I sent you. Okay, what is the size of the smallest angle in triangle A? Give your answer correct to 1 decimal place and show your calculations. So in our next, or in unit 9 is where we're going to do trigonometry. So this requires sine, tangent, or cosine. So we are going to just skip this. I'm going to give you the answer. It's 36.8. But I'm not going to show you how to do it because you haven't learned it. And we are going to learn it in unit 9. So until we learn our trig functions, we're not able to find the missing angles yet. The diagram on the next page shows the layout of some Hopewell earthworks. The centers of the Newark octagon, the Newark square, and the Great Circle were at the corners of the shaded triangle. The 3 right triangles surrounding the shaded triangle form a rectangle measuring 12 units by 14. Okay, so we have 12 by 14. Each of these 3 right triangles is similar to one of the Hopewell triangles on the previous page. For example, triangle 3 above, so triangle 1, triangle 2, I'm not sure which one they're saying is triangle 3, is similar to Hopewell triangle C. Okay, 1 and 1, which means this is triangle 3 then. It just has a scale factor of 5. If you multiply triangle C, which has a base and height of 1 and 1, by scale factor of 5, you would get triangle 3. Okay, so number 3 asks, which Hopewell triangle is similar to triangle 1? So here's triangle 1. Its sides are 9, 12, and 15. So looking at this triangle, go ahead and flip back and see which triangle is similar on the first page to this triangle 1 with sides of 9, 12, and 15, and then send it to me in the chat.
Bless you.
Excuse me. Thank you, Jose. Yay. Yep. Very good. Okay, yes, so it is. It is triangle A, the 3, 4, and 5. We can prove it. If we do 3 over 9, that's equal to 4 over 12, which is equal to 5 over 15. Because 3 over 9 is 1/3, 4 over 12 is 1/3, and 5 over 15 is 1/3. Sorry. So how we decided is all the corresponding sides are proportional. Okay, and then number 4, is the shaded triangle a right triangle? Okay, so remember how we determined if it is a right triangle is using the Pythagorean Theorem Converse. So that was from last unit as well. But remember the Converse says that if a squared plus b squared equals c squared, then we know that it's a right triangle. So we need to see if a squared plus b squared equals c squared to determine if the shaded triangle is a right triangle. So there's some work involved here. So first we need to find, so the only side we know is 15. So we need to find these other two sides and then plug in all the sides to a squared plus b squared equals c squared. So let's start with triangle 3. So this would be the hypotenuse that we're missing. So that's going to be C, and we have our base and our height, which are A and B. So we get A squared, which is 5 squared, plus B squared, which is 5 squared, equals C squared. 5 squared, that's 25, plus 5 squared, which is 25, equals C squared. 50 equals C squared. We take the square root. And C equals, we just did that. I think it was 7.1, right? Yep. Okay, so now we know this side. Now we just need to find this side. So again, we have A and B, and we need to find this side, C. So 14 squared, that's A squared plus B squared, which is 7 squared, equals C squared. So 14 squared is 196, plus 7 squared, which is 49, equals C squared. 196 plus 49 is 245, which equals C squared. So then we need to take the square root, and C equals 15.65. Which we might actually, rather than doing decimals, maybe we'll just leave them as square roots because that's easier in Pythagorean theorem. So this side is the square root of 245, and this side would be the square root of 50. Okay, so let's sketch our triangle that we're trying to figure out since it's so messy up there. So we know this side's 15. We know that this side's the square root of 50, and this side is the square root of 245. So now let's see if a squared plus b squared equals c squared. So this, our hypotenuse is c right here, the square root of 245. So we'll call this one a and this one b. So we get 15 squared plus the square root of 50 equals c squared, which is 245 squared. So 15 squared, that's 225. And then the square root and the square, those just cancel each other out. So this is 50 equals, those cancel each other out as well, 245. So if we add these together, we get 275 equals 245. So a squared plus b squared does not equal c squared. So then we know that no, it is not a right triangle. Because a squared plus b squared does not equal c squared. Any questions on the problem solving?
No.
Okay, you guys want to go ahead and open up Canvas then? We can work on the study guide, and then all you have left for the week is the study guide and the test. So I will share Canvas. Well, let's see. I still want this open, I think. But let me open up Canvas as well so we can look. Okay, so if you guys want to hop on Canvas, we can work on the study guide together. So I'll go to geometry and then modules. And then we're in unit 7. Week 6. So Thursday is the unit 7 study guide. So you're going to click this one. Okay, so remember we started off the unit with dilations. So number 1 is asking you to write a rule to describe each transformation. Where's my, oh, there it goes. So we're looking for the scale factor. So how much larger or how much smaller did that shape get? She had you type it in. So there, it was supposed to be multiple choice. Okay, so let's look at point L. So L is at -1, 1. And then L prime is at -2, +2. M is at 2, 2. And then its dilated M, or M prime, is at 4, 4. So what are we doing with L and M to get L prime and M prime? So -1 to -2, 1 to 2, 2 to 4, and 2 to 4, we are multiplying by 2, right? So that means this has a scale factor of 2. So I'm not exactly sure, but the wording, but we'll say a dilation of 2. Okay, and then number 2 is the same thing. So let's look at some of the points and see what happens to them. So C is the point 2, 2. And then C prime is at 1, 1. So what's happening to our numbers going from 2 to 1 and 2 to 1? It is cutting in half. So this would be a dilation of 1/2. Any questions on the dilations? Where did my chat go?
No.
Okay. Number 3, state if the polygons are similar. So remember, you have your notes to reference. But we're looking for, are they the same shape? Does it have corresponding side? Are the corresponding sides proportional? And are the corresponding angles equal? So yes, they're the same shape. They're both rectangles. The corresponding angles are equal. They all have 90-degree angles. So now we just have to determine, are the sides proportional? So is 7 and 14, those are corresponding sides, equal to 8 over 20. So 7 over 14, that is 1/2. 8 over 20, if we divide by 4, 8 divided by 4 is 2, and 20 divided by 4 is 5. That's 2/5. So then we know that those are not similar. I have a visitor. Can you say hi to everyone, Tate? Right here. Say hi. Okay, now you have to go. Okay, and then let's do the same for number 4. And number 5. So you guys go ahead and do number 4 and 5 on your own, and then send me what you get in the chat, and then we'll go over them. Okay, good. I'm getting all the answers coming in. And for number 4, if you got that they were similar, you are correct. 8 over 40 is 1/5, and 4 over 20 is also 1/5. So they're the same size, or they're the same shape. Their angles are, their corresponding angles are congruent and their sides are proportional. So the main one is that 8 over 40 is proportional to 4 over 20. So this is 1/5 and this is 1/5. And very good on number 5 too. Same thing, so they're the same shape. Their corresponding angles are equal and their sides are proportional. So you guys were correct. Number 5 is also similar. If we set up our proportions, we would do 5 over 30 equals 8 over 48. And 5 over 30, if you divide by 5, that's 1 over 6. And 8 over 48, if you divide by 8, that is also 1 over 6. Excellent. My document camera is frozen. Okay, number 6. So now we know they're similar. So now we just need to find the missing side length. So go ahead and try number 6 and send me what you get. And I'm going to restart my document camera. Okay, bummer. My document camera is not working. Okay, but we could do it without it. So we have 6 down here for the base of our small one, and then 12 for the large one. So really you can see that 6, if we multiply by 2, that's 12. So we can just do that to find the other missing side. So if this side is 4, if we multiply 4 by 2, that would mean this side is 8. We could also set up the proportion and cross multiply too. Let's see if it will turn on, then I can show you. Oh, yay. Okay. So we could also say 4 over x equals 6 over 12. And then we would cross multiply. 48 equals 6x. And when we divide by 6, 8 equals x. Okay, go ahead and do number 7. Good, you guys are right. It is 7. So 6 times 2 is 12. So what times 2 is 14? That is 7. Number 8, the polygons and the pair are similar, find the missing length. So the same thing. This one's a little bit harder. You might want to set up your proportion. So you can say 16 over 20 equals 28 over x. We cross multiply, 16x equals 20 times 28, which is 560. We divide both sides by 16, and x equals 35. Any questions on number 8? Okay. Number 9, we need to state if the triangles in the pair are similar. So we're going to be using our similar triangle theorem notes. So remember, side, side, side. If 3 sides of one triangle are proportional to the corresponding 3 sides of another triangle, then we know they are similar. If 2 sides of one triangle are proportional to the corresponding 2 sides of another triangle, and the included angle between the 2 sides of each triangle are congruent, then we know that those triangles are similar. Or if 2 angles of one triangle are congruent to 2 angles of another triangle, then we know that they are similar. So let's look at number 9. And see. So it looks like we have angle F is congruent to angle L, and angle G is congruent to angle M. So if we look at our theorems, we have 2 angles that are congruent, which means they are similar because of angle. So we would click this one, AA similarity. And number 10, state if the triangles are similar and how you know they are similar. So remember, when we have vertical angles, these angles are equal. So they do have this angle in between. So we need to check if side angle side would work, because we can't do side 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 and we can't do angle angle. So we only know one angle, but we know 2 sides. So let's see if the sides are proportional. So we have 10 and 70. So 10 over 70, is that proportional to 11 over 77? 10 over 70 is 1 over 7 if we divide by 10. And 11 over 77, if we divide by 11, that is 1 over 7. So yes, the sides are proportional and the angle between them are congruent. So these are similar because of side angle side. Okay, go ahead and submit your quiz. And yeah, I'm curious to see what question 1 and 2, if it's going to give you full credit, because I'm not sure what our course designer put in for the answers, because it was supposed to.
It says dilation to above the origin, so we got it wrong.
Oh, it's saying a dilation of 2 about the origin?
Yeah.
Okay.
Wait, what was number 8 again? My bad.
I couldn't hear you really well. Like I like cut out while you were talking about
Oh,
that
no
problem.
problem. It's 35.
Okay, thank you.
Okay, so you guys want to go through it again then? So dilation of 2 about the origin. I'm going to see if I can go in and fix this to be multiple choice. Okay, so if you have to go through and do it again, since number 1 and 2, we didn't put about the origin. Okay, now are you guys getting 100%?
Yeah.
Okay, perfect.
She wants me to do some practice now, but I don't know what the page is. She said she's gonna come on and help.
Probably the checkpoint at the end of your chapter review for chapter 6, because you have a chapter 6 test tomorrow.
Yeah, she wants to wait.
Okay, so you guys are all set then. For the week, all you have left to do is your test. So on Canvas, that looks just like this study guide. So any questions before I let you guys go? Okay, and then Elijah, if you could stay on for a minute, that would be great.
It made me get it wrong just because of the capitalization error.
Oh my goodness, this is why it's not. This is why I didn't want you guys to have to type anything in. It should have been multiple choice. So sorry, Jade. Yeah, that's annoying. I'm going to fix it, hopefully, once I'm done.
Wait, we can't be able to do the test today?
Sure, yeah, you could do it today if you'd like.
It's like popping up as like a blank screen. That's what I was wondering.
Oh no. Okay, let's see. So Friday, Unit 7 test. Oh my goodness. Oh, it looks like it hasn't been put in. Darn. Okay, I'm going to email the course designer right now, and hopefully she can put it in today because it was supposed to be put in weeks ago. So I'll send you guys an email when it's up.
Okay.
Darn. Okay, so luckily it's only Tuesday though. And so you're done with all of your work through Thursday. So it's just this one, which maybe she knew that it wasn't due till Friday. I'm not sure. Okay, so you guys are free to go. I'll send out an email when the Unit 7 test is up there to you guys. So you can go in and finish your work for the week. Okay, and Elijah, we're gonna do some of those missing assignments. Let me see if I can get, there's supposed to be one other student that has like the same missing assignments as you that I want to be here. Not sure who her teacher is. Let's see. Mhm.
Is it because if Dad looks on the real math, is it chapter 6 review test?
Yeah, I think so.
Okay. Just because the Daddy said Daddy looks at the real math book, and I was just wondering.
Yeah, I think it is in your real math book. It's at the end of chapter 6.
Yeah, but is that what I'm doing today? Said that's for tomorrow. I need to do my practice math book to practice on it.
Oh, okay. I don't know.
And you don't know the pages for practice math.
Okay. Okay, Elijah, so let's get started. Now just you and me, and then hopefully we'll see if we get one more student on. So is everything that you've done turned in, just so we don't do any assignments that you've already done that you just maybe haven't uploaded?
So far everything I've done is turned in.
Okay.
I don't think there's too many left. I think I have to do I would like to retake the study guide from, I think it was last week or maybe the week before. And then there was the application, I think, too.
Okay.
And then I forgot where that was from. And unless that was what we just did right now, which I don't think that's the case, but let me check real quick. So, oh yeah, I have to do Unit 6 application, and then what else? There was another one. unless that
Okay.
was something like that. I don't think I have as many missing assignments because I did get a lot done last week with you.
Perfect. Okay. So let's start with the Friday 6.2 checkpoint. Because I already have videos of like those application assignments that you're missing and the review assignment. So I'd rather work on the other ones that I don't have videos for, which would be the
The
Friday 6.2 checkpoint and then the unit test. And the unit test, gosh, if we do the unit test, that'll really raise your grade
Yeah.
because that's 50 points.
Okay, yeah. Real quick, let me grab my charger. I think my phone is gonna
Okay.
my computer.